Good morning. This is Ms. Billerbeck, and we're going to talk about 3.3 factorization by using special products of algebraic expressions. So we're going to talk about going the opposite direction now. Before we learned about going the forward direction with the special products. So if you remember special products, we had a plus b squared is a squared plus 2ab plus b squared. And all these, as they're being multiplied out or expanded out, now we have it expanded out and we're going to factor them. So this is the opposite direction. So let's look at what we've got. So if we have a squared plus 2ab plus b squared, that's just going to be a plus b quantity squared. We have a squared minus 2ab plus b squared, that's a minus b squared. So the difference is just this sign and that sign. Now this is called the difference of squares. So when we see that, we know automatically it factors as the quantity a plus b times the quantity a minus b. Or if we use the commutative property of multiplication, it's the same thing as the quantity a minus b times the quantity a plus b. Let's do some examples to figure out how does this work. So if we see this, and we break it down, this is z squared minus 2 times 8 times z plus 8 squared. Well, there you have it. We have a equals z and b equals 8. So we can say, well, this is just going to be z. Oh, but we have a minus sign. So we have to be super careful. It's not plus. It's going to be a minus. So we have to double check. So minus 8 squared. Okay, so got to be careful. What is this sign? This is always going to be a plus, but what is that sign? And that's what goes right here. All right, so this one, well, we know that the 100 is 10 squared m squared minus, and we know one of these is 10, so we have 2 times 10. Okay, so that gives us, to get 140, that would give us a 7 mt plus, and this is 7 squared t squared. Okay, so this is a would be 10 m, because we have 10 and m. Okay, b looks like it's going to be 7t. Okay, so if we check this one, we have the 2 times a. Let's even put them together, so it's easier. So a is 10m times 7t. So we have a times b, and then that's b squared. So now we know how to put it together. So this one's going to end up being a is 10m. That's a minus sign, so we're going to put a minus sign right here. And then b is 7t. And now we're going to square. So it's like a puzzle. You just have to figure out how to break this puzzle up. But it's going to fit this formula right here. If it says these are special products, then you know you're using a formula, one of these formulas. Okay? So, so we had a squared minus the 2a times b plus b squared. And then we were able to put it into this formula. Okay, there you go. All right, so that's what we did. So a times 2ab plus b squared. Oops, that goes right there. All right, let's look at the next example. There we go. Okay, so this one says factorize each of the following. So we're going to do the same thing. So this time we're going to see, oh, 16. That is just 4 squared hiding. So we have 4 squared x squared plus, we know in the special formula that there's a 2 here, and 2 times 8, or 2 times 4 is 8, and we're pretty sure a is going to be 4x. And then we need a b. Well, we have nothing left, but this is a 1, so our b is 1 plus 1 squared. Well, 1 squared is just 1. Okay, so we have a equals 4x, b equals 1. So when we factorize this using special products, and we remember that's a that's a plus sign. So we have 4x plus 1 squared. And sorry for my voice cutting out still. It's looking like it's becoming a smoky day again here in California. Okay. All right. So that's how we would do the factorization of this as a special product. Okay, let's look at this one. Well, 9 is 3 squared. So 3 squared u squared plus, and then we have a 2 here, 2 times 6. So we have to come up with a 6, but we're pretty sure a is 3u. So a is looking like 3u. So let's put in a 3u there. And then that's 6. 12 divided by 6 is a 2, and we have a v hanging out there, so we're pretty sure that's going to be b. And then this is 2 squared v squared, and sure enough, b is 2v. Okay, so that's how we break that all up. So now we have a and b. We can use this special formula. And we have a plus sign here. So a is 3u plus 2v squared. So we just made this very difficult factoring problem. We found out by breaking it apart like a puzzle what a and what b were, and then we applied the special products factoring formula. All right, let's try a different one. This one, we're going to use difference of squares this time. So difference of squares is a little different than the other two. So it's a squared minus b squared. And then we have the quantity a plus b times the quantity a minus b. Okay, so they're the difference of two squares, and then all they are is alternating signs, which makes that middle term, the two ABs, don't add. It's a plus AB minus AB, so plus AB minus AB goes away. So that's why we have no middle term here. So let's look at what it will look like here. So 64 we know is 8 squared. And then k is just k squared. So our a is going to be 8, and our b is going to be k. So we're going to factor this as 8 minus k, 8 plus k, which is exactly the same thing as 8 plus k times 8 minus k. So don't worry about, well, does the plus sign go first or second? No worries. Just make sure your signs are alternating. dividing. That's all that matters. Okay, so we have 2 squared p squared minus, and 81 is 9 squared q squared. So judging from this, I have an A is a 2p, a B is a 9q, and I'm going to write 2p minus 9q times 2p plus 9q. And again, you could have written it with the, 2p plus 9q, 2p minus 9q. It's the same thing. Here's 1, 5 is not a square. What are they doing? No. Well, let's take the 5 out because there's a 5 in both of them. When we divide 5t by 5t, in fact, let's do it very thoroughly. So if I want to take a 5 out, that means I'm doing 5t squared divided by 5 minus 20 divided by 5. So I'm just going to, whoops, that's a 5. My goodness, my mind's ahead of me. There we go. So I'm going to factor that 5 out, because if we recall, 5 over 5 is just 1. So if I divide everything by 5 and multiply everything by 5, I haven't done anything to the equation. Fancy little math move, eh? So now I have 5 out here. Well, that just goes away. So I have t squared, and then 20 divided by 5 is 4. And then we can say, wait a second, hold on. I know what that is. That 4 is a 2 squared. So my A is t, and my B is 2. So I'm going to say this is going to equal 5 times t. I'm going to switch it up on you guys. I'm going to put a plus first, just so we don't get into any ruts. And then t minus 2. Okay, so A is t, B is 2. So 5 times the quantity t plus 2 times the quantity t minus 2. All right, so that's how we do difference of squares. So let's look at, well, what if we have a problem with just numbers? Let's take a look at what that would look like. Well, that's a square, so A is 463 and B is 453. Okay, so this this is just 463 plus 453 times 463 minus 453. Let me write this down here. That's not good. So we're going to get 463 plus 453 times 463 minus 453. There we go. Okay, so if we add this together, this 3 plus 3 is 6. 5 plus 6 is 11, carry a 1. 4 plus 4 is 8, plus 1 is 9. This is just 463 minus 453 is just 10. Well, that makes it easy. We just add a 0 to that. So we just did a very brutal calculation using the special products formula, and we got our answer so quickly without using a calculator. Wow, isn't that powerful? All right, so that's it for factorization by using special products of algebraic expressions. And I hope that you have a fabulous day. Bye-bye.